Okay, so let's go through our family of graphs, I guess, our gallery of graphs. So initially we've got our rectangular hyperbolas. Um, Hopefully we remember our basic shape. We know that the denominator can't be zero. So in this case here, graph of 2 over x minus 1, the whole graph has moved 1 unit to the right. So remembering we should always use a ruler. There's my vertical asymptote at x equal to 1 and a corresponding y asymptote at y equal to 0. We know it's a positive hyperbola or a trunk positive hyperbola. We should really pick at least one point the graph goes through. So maybe there at x equal to 2, if I put 2 in there, I get 2 over 2 minus 1, which is 2 over 1, which is also 2. So we'll call that the point 2, 2. And so we've got a graph that looks a little bit like that. And we can label that point as 2, 2. I know the scale doesn't match perfectly, but as long as we label a point, y-intercept is a bit easier. Put x equal to 0, and we'll get y equal to 2 over negative 1, which is negative 2. So I'll call that the point negative 2 just for ease of graphing. It's not a very good graph, that one. It's a bit better. And we'll call that point 0, what did we say? 0, negative 2. So we've got our vertical and horizontal asymptotes labelled, and we've got our intercept labelled. For B, obviously the 3 is the only shift, so the whole graph moves up 3 units. So perhaps instead of trying to sketch it on the same thing, we might just do a quick sketch over here. So my horizontal asymptote has been moved up 3 units. So it's now at the point y equal to 3. No horizontal shift. So my vertical asymptote is still at x equal to 0. Positive asymptote, positive graph, so we know it's sort of in the top left corner. And we know, top right corner and bottom left corner. Let's find out that point in particular. So if we put y equal to 0, I get 0 is equal to 2 over x plus 3. Negative 3 equals 2 over x. Multiply the x over. Negative 3x is equal to 2, so x is equal to negative 2 on 3. So that's the point negative 2 on 3, 0. Obviously, look, that's a very badly drawn line up here in the top right corner, but you do a much better job with graphing. It says we should put our domain and range for each. So for A, the domain obviously is everything except for at x equal to negative 1, so R except for 1. And the range is R except for where y equals 0, the asymptote. Similarly for graph B, my domain is all the reals except for x equal to 0. And the range is all the reals except for y equal to 3. Okay, so it's good practice getting the habit of sketching our, or at least stating our asymptotes. Stating the domain and range. So moving into our next example, we've got 1 unit left and 3 units down. So let's go. Let's say 1 unit is half. So we'll call that x equals negative 1. 3 units down would be maybe here. Y equals negative 3. It's a positive trunkus still. Just to get an idea of where we're cutting, let's get our y-intercept. So y-intercept, let's put x equal to 0. I get 2 minus 3, which is negative 1. So we've got a y-intercept at negative 1, which we'll call that there. So that makes it a bit easier now. We know that my x-intercept is obviously going to be negative. And we go a little bit like that. And my other line will be down in here somewhere. Yeah, so let's find that x-intercept. Put y equal to 0, so I'll get 3 is equal to 2 over x plus 1. Bring the x plus 1 across. and divide the 3 back. And now we subtract 1. So that's the point, negative 1/3, 0. Quick domain range. Domain is obviously R except for that asymptote, which is at -1. And the range is R except for the horizontal asymptote, which is at -3. Let's cheat a little bit. We'll put this last one on the same axis. What have we got? We've got 1 unit to the left again, so we can have the same vertical asymptote. This time there's no up and down. So the horizontal asymptote is at y equal to 0, x equal to -1. Put x equal to 0, x equal to 0, y is equal to -2/1, which is -2, which puts us at about, we'll call that -2 this time. So since it's a negative hyperbola, we're in the bottom right and top left. So this time our graph works a little bit that way. Domain and range doesn't change a real lot though. Domain, we've got R except for what? -1. And the range is R except for 0, isn't it? Okay, so again, I guess the key features, hopefully remember, it's our horizontal shift, translation of H units to the right, vertical shift, K units up and down, and there's our dilation there. Out there like that, it's our dilation from the x-axis, okay? Sometimes it's not immediately obvious what the graph is. We've got to look at what the graph is we have. So in this instance here, we can see that the powers of the x coefficient, the powers of the x term is 1 on the numerator and also the denominator. So we can do a division first. X plus 1 goes into 2x plus 5. So 2 times 2x, 2 times 2, 1 is 2, subtract, I get 5 minus 2, which is 3 remainder. So I get 2 remainder 3, which is the same as saying 2 plus 3 over x plus 1. So in actual fact, that's another form of the same function. So that's really the key kind of division that we have. And clearly from here, it's a hyperbola with a shift 1 unit left. So let's make that 1 unit left at x equal to -1. 2 units up. Let's change that, just so our scale's a bit better. So can I make that 1 unit left? X equals -1. I can make that 2 units up. At y equal to 2, positive hyperbola. So I'm expecting an intercept there somewhere. And probably here somewhere. By rights, I should work those out first, and I'll do that now. So y-intercept, let's just put x equal to 0. It's just as easy to put it in 0 there, and I end up with 5 over 1, which is 5. If I put it over here, I'm going to get the same thing. So what's that, my y-intercept? So we'll call that the 0.5. The scale's probably not great, but that's okay. Also got the x-intercept, so we've got our x-intercept. We'll put y equal to 0, which in this case is probably easy to do it over here. So if I put 0 is equal to 2 plus 3 over x plus 1, -2 equals 3 over x plus 1, -2 x plus 1 equals 3. Hopefully we're getting used to doing this manipulation. -3 on 2 minus 1, which equals -5 on 2. Does that seem reasonable? Probably. If that's -1, that could easily be -5 on 2, 0. Finally, stating a domain and range. Well, the domain we can get from both forms, can't we? Both of them are going to be R except for -1. My range, not so obvious in the top form of the function. So undo that. My range is going to be R except for, as it turns out, 2, which isn't obvious in this form of the graph. All right, so that's really the key kind of division we have. What's our last question there? So it says determine the equation for the hyperbola. So what have we got there? So we know it's a hyperbola. It's a -1 from the looks of things, but we may not put that in straight away. A over, so clearly we've shifted 2 units to the right, x minus 2, and 4 units down. So that covers, there from my asymptotes, 4 units down, 2 units right. We've just now got to think about a dilation factor. So we know it goes through the point 0, 0. So if I substitute 0, 0 in, I get 0 is equal to A over 0 minus 2 minus 4. Take the 4 over. 4 is equal to A over -2. -8 is equal to A. So in actual fact, my graph is y equals -8 over x minus 2 minus 4. So really pleased that we've got the negative sign there, which we expected because we're in the top left and bottom right quadrants. State the domain and range now. So the domain again, R except for 2. And the range is R except for -4. Okay, so now we move on to our truncus graph. Hopefully, obviously the key feature of our truncus compared to our hyperbola is the x squared factor in the denominator, which straight away should tell us that we're only typically going to get positive values. So my standard truncus graph looks a bit like that. So this one has been shifted 1 unit right, so I'm going to work with half units again. So x equal to 1. Horizontal, we haven't moved up or down at all. Y equal to 0. Let's put x equal to 0. At x equal to 0, y is equal to 1 over -1 squared, which is 1. So we'll make that 1 there. So let's go. There's my graph. And really, there should be a touch of symmetry about the graph about that asymptote. So our graph looks a little bit like that. Again, it doesn't ask for it. For the domain is R except for that point there, 1. The range, however, let's keep thinking about that. It's going to be 0 to positive infinity. Okay, we'll never reach 0. We're never going to reach the asymptote, but we'll go as high as we feel like. As opposed to something like B, where there's no horizontal shift, but we've moved up 2 units. So we're clearly up at y equal to 2. Vertically, we haven't changed, so we're at x equal to 0. Since we're not going to get any y-intercept because it's an asymptote. And if we try and solve for a x-intercept here, we'd get -2 is equal to 1 on x squared, which implies x squared is equal to 1 over -2. And remember, we can't do the old square root of a negative number, yeah? So there's no x-intercepts, which is what we expect because the whole graph moved up. Again, domain R except for 0. That's a bad bracket. And the range except for, well, hang on, what is the range? It's not R at all, is it? The range is from 2 to positive infinity, round brackets on both. What's the last one? We've got a bit of a combination. So what are we going to do? We're going to go 2 units right because of that x minus 2. And we're going to go 3 units up, which I'll put there. Y equal to 3. And let's do our, again, we're going to have a y-intercept this time, so hopefully it'll be something above 3. If I put x equal to 0, I get y is equal to 1 over negative 2 squared plus 3, which is 3 1/4, which makes a little bit of sense. It fits in, doesn't it? Again, domain is R except for that asymptote at 2, and my range is from 3 to positive infinity. All right, so hopefully, you know, we've worked with our truncus. We've got a bit of a feel for what that looks like. All right, my square root function. Don't forget, the square root function is really the graph of x equal to y squared, except we don't have a plus or minus out the front. Okay, we're just in this case looking at positive root x. And so there it is there in blue. There's the root x. Obviously, in red, negative root x, it's a reflection about the axes. So the y values become negative, so we're flipping it upside down. If we got the negative sign inside, so let's specify reflect about y axis. Okay. Oops, sketch the graph of negative root x. Well, obviously this one here, I wonder if maybe I was supposed to put a negative sign in there so it matches off to this bottom left corner. But either way, I guess as it's written, whoops, as it's written, the graph of negative root x is the graph of root x reflected, isn't it? So there's negative root x there. Yeah. So we've got anything else there? Yep. So then we have our cube root function. Okay, so instead of the square root of x, this one's slightly different. Our cube root function is the graph of x equals y cubed. So if we rotate our graph 90 degrees, you can see it's really just a graph of, it's a cubic graph that's drawn about the x function, the x-axis. So things to note, as the biggest difference between the square root and the cube root, the domain of the cube root is R, because you can take the cube root of a negative number. The range of my cube root is also R. So that's true for any odd power. X to the 5 will look very similar. If I was to draw the 5th root, it'll just get, oops, it'll just be a little bit skinnier in here and a little bit flatter in there. Okay, but it will see x to the 5, x to the 7, the 7th root, the 3rd root, 5th root, 7th root, etc. All right, so that's just to remember the cube root function, a bit like a cubic, except it's defined over all of R. Okay, it doesn't stop. So if we do a few graphs here. So again, remember, before we work out what sort of transformations have taken place, let's write everything as the coefficient of x being 1. So what it means there, it means I've got to put a negative 4 there, and I've got my plus outside. So if I multiply in here, I get negative x plus 4, which is what we have there. So clearly now, I've got to reflect. I've got a 4 units right, and I've got a 1 unit up. So let's think about my original graph. My original graph is something like that. That's square root x. So a negative inside the bracket is going to cause it to go like this. Yeah. And then I've got 4 units to the right, which we'll call that 4 units there, and 1 unit up, and we'll call that 1 unit up. And so then the graph is going to look something like that. So that point there is the point 4 units right, 1 unit up. Now you can see from the graph what the domain should be. So let's think about the domain just from an algebraic approach. We need 4 minus x to be greater than or equal to 0. Take the x across. So x greater than, or sorry, 4 is greater than or equal to x. So x has got to be less than or equal to 4. So my domain is what? Is from negative infinity to 4, which matches off from negative infinity to 4. So that's a good sign. Okay. My range obviously comes as low as 1 and then continues up. So my range is from 1 to positive infinity. Now, it doesn't look like it's getting very big very quickly, as in going up that way, but it does. It continues to increase over time. So my maximal domain is there in green. My range is in blue. Let's find a y-intercept just to see if we're right on the right track. Put x equal to 0. Y is equal to the square root of 4 plus 1, which is 2 plus 1, which is 3. Which kind looks really quite feasible, doesn't it? So everything seems reasonable. All right. What about my cube root graph? What's that one looking like? A little bit different to us. So my cube root is that one. Okay. What's happened to the graph? Same sort of thing. Minus x minus 4 minus 1 this time. So I wonder if I can get away with sketching it above since we've come down 1 unit. Maybe we can. So my original graph, let's go to red pen, is in there. So what's happened? It's reflected about the y-axis. So look where it is now. So it's really going to come this way, isn't it? It's going in the opposite direction sort of thing. And then we're 4 units to the right. So that point there at 0, 0 is going to go 4 units to the right, which we'll go back to the main axis, 4 units to the right and 1 unit down, which we'll call there. So where the y-intercept is, so the back half, it's going to look like that, but whereabouts are our intercepts exactly? So maybe let's find them out. So if I put x equal to 0, y is equal to the cube root of 4 minus 1. Now, so what does that mean, the cube root of 4? So the cube root of 4 is somewhere between the cube root of 1 and the cube root of 8. Cube root of 8 is 2. The cube root of 1 is 1. So this value here is greater than 0. Yeah. So my x-intercept is here somewhere. It's a positive value. So we can give that a value of cube root of 4 minus 1. Y-intercept. Oh, that was the y-intercept. Oh, okay. That was the y-intercept. Let's undo that a little bit. My bad. So the same principles in that it's a positive value. So let's just call it there. So it's cube root of 4 minus 1. X-intercept, put y equal to 0. So I get 1 is equal to the cube root of 4 minus x. Cube both sides, so 1 cube is equal to 4 minus x. X is equal to, take the x across, the 1 across, 4 minus 1. So x is equal to 3. So 3 is about there. So my graph looks a little bit like that. Okay, that probably should be increasing a little bit in reality. And we probably could just label that key point there as 4, negative 1. Okay, that one there is the point 3, 0. What's the domain? Domain is everything. The domain is R. The range is also R. Okay, because we can have all values. So it might take a little bit of getting used to that one. Let's have a look at these last two before you go and do some. Back to a square root graph. So we're meant to do our own axes. Again, what's happening? Coefficient of x is already 1. Negative on the inside means we're reflecting it back out that way. 1 unit to the right, 1 unit up. So it's pretty straightforward, isn't it? So that's our starting point with reflecting in the other direction. We'll go right 1, we'll go up 1, and then we'll just draw our half a parabola. We'll give that the point 1, 1. Let's find our y-intercept. Y-intercept, put x equal to 0. I get y is equal to the square root of negative 1 plus 1. So square root of 1 is 1, plus 1 is 2. So that's the point 0, 2, 1, 1. Quick domain. Clearly from the graph, we've got from negative infinity to 1 inclusive, and the range is from 1 to infinity going up. We can confirm the domain just by algebra. I need negative x minus 1 has to be greater than or equal to 0. So if I sort of divide both sides by negative, it means that x minus 1 has to be less than or equal to 0. X has got to be less than or equal to 1, which corresponds, I hope it does. All right.